Thank you for the introduction. I'm Sato from Joyride Meals. My utmost gratitude for giving me this opportunity to make a presentation today. Natto, a well-known traditional Japanese food, contains Menaquinone-7, a form of vitamin K2. We, Joyride Meals, have focused on Menaquinone-7 over the years and have established a fermentation method for the production of Menaquinone-7 using natto bacteria. This has led us success in commercializing it. It has been found that Menaquinone-7 can be used in smaller amounts than other forms of vitamin K, while still providing the equivalent health benefits. Although it is now being widely used in many countries around the world, there is still a lack of awareness about vitamin K. We therefore hope more researches will be done. We hope that through this vitamin K2 study group and this international symposium, broader research and application of vitamin K can be promoted. Today, I would like to share with you our clinical studies on Menaquinone-7 while focusing on its mechanism of action. There are two types of vitamin K, vitamin K1, which is produced by plants, and vitamin K2, which is produced mainly by microorganisms. K1 is a single compound, also known as phytoquinone, whereas K2 is a group of compounds called menaquinone, and is classified as menaquinone-4 to menaquinone-15, depending on the length of its side chain. Vitamin K acts as a cofactor for the enzyme gamma-glutamyl carboxylase in the conversion of specific glutamate residues of vitamin K-dependent protein into gamma-carboxyl-glutamic acid, which is shown here as GLA. Therefore, if the intake of vitamin K from food is insufficient, the vitamin K-dependent protein is not activated and its function is not manifested. When vitamin K obtained from food is absorbed in the small intestine, chylomicron is formed, and after passing through the lymphatic tube of the intestine, is stored temporarily in the liver. As blood coagulation-related factors are produced here in the liver, vitamin K is used extensively. Some of the vitamin K is also incorporated into lipoproteins, which are transported to the tissues through the bloodstream. This is a table summarizing many vitamin K-dependent proteins. As all proteins containing GLA are vitamin K-dependent, these proteins all contain GLA. Surprisingly, these GLA-containing proteins are very common in the body, and about 15 different types are currently known. Presently, GLA proteins with unknown functions are still being found. The most well-known vitamin K-dependent proteins are the many blood coagulation factors, which was produced in the liver as vitamin K-dependent proteins. Vitamin K is thus considered to be an essential factor for normal blood coagulation. On the other hand, other than the liver, it is also believed that osteocalcin, a vitamin K-dependent protein that is produced by osteoblasts, is an essential factor in the regulation of calcium metabolism in bones. More recently, some studies have pointed out that osteocalcin also plays a hormone-like role in sugar and testosterone metabolism. Beside bone, matrix GLA protein, a protein that inhibits ectopic calcification, are produced by the arteries and soft tissues. A variety of other factors that inhibit ectopic calcification have been identified to be vitamin K-dependent proteins, suggesting that vitamin K may be able to promote bone calcification through action on osteocalcin and inhibit the accidental adhesion of calcium to arteries by activating matrix GLA protein and other GLA proteins. Consequently, vitamin K can assist calcium in mobilizing into the right place, where it is needed, and prevent it from being deposited in arteries and soft tissues where it should not be. This shows the daily required intake of vitamin K. WHO suggests the daily required amount of vitamin K to be 65 micrograms per day for adult men and 55 micrograms per day for adult women on the basis of 1 microgram per day per 1 kilo body weight. On the other hand, in the United States, the recommendation is a bit higher, while that of EU does not fall far from that of WHO. Although the recommended amount in Japan is similar to that of WHO, in 2015, the figure doubled. One should bear in mind that these recommended daily intakes of vitamin K are based on the amount of vitamin K required to maintain normal blood coagulation. Although 1 microgram of vitamin K per day per 1 kilogram of body weight is considered essential for the regulation of blood coagulation, not much was known about its effect on bone, and hence we conducted a clinical trial to assess this. Healthy individuals were instructed to take in a total daily amount of 72 micrograms of vitamin K divided in 3 meals for a month. The results showed that after 2 weeks of consumption, through assessment of the osteocalcin activation indexes, deterioration was observed and the condition only worsened considerably 4 weeks later. Next, it is the relationship between natto and bone health. Apologies for this English-only slide, as this was an international symposium and I wanted to explain what natto is. In the past, natto was made by using Bacillus subtilis that was present in straw. When soybeans are boiled and then wrapped in steamed straw, the heat will kill all the normal bacteria and miscellaneous germs. However, being heat-resistant, Bacillus subtilis will survive and thereby thrive in number. Within Bacillus subtilis, it is thought that when adequate bacteria are allowed to thrive, delicious natto can be produced. After the war, pure culture was already started being used, and at present day, natto is manufactured this way. Since natto has some very distinctive features, some may like it while some cannot even eat it. It is a food that you like or dislike clearly. These are the major forms of vitamin K found in food. Green and yellow leafy vegetables contain high levels of vitamin K, and they are the main sources of vitamin K in our daily diet. On the other hand, animal products such as egg and meat also contain minute amounts of Menaquinone-7, a type of vitamin K2. Long-chain vitamin K2s are widely found in yogurt, cheese, and other fermented food, but only natto from fermented soybean contains exceptionally high levels of Menaquinone-7. In short, the main source of vitamin K is mainly green and yellow leafy vegetables for vitamin K1, meat for MK4, and most importantly, natto for MK-7. This is a study that measured vitamin K levels in the blood of patients with femur fractures. Compared with healthy subjects, the blood levels of vitamin K1 was the same in both groups, but the levels of Menaquinone-7 were low in fracture patients. Since Menaquinone-7 is derived from natto, this study led to many studies afterwards that are on natto, vitamin K, and osteoporosis. And this is the regional correlating study that was conducted by the same group of researchers as the previous one. The relationship between hip fracture risk and natto consumption was looked into. They found that the lower the consumption of natto, the more fractures there were in the region. And inversely, the higher consumption of natto, the fewer fractures were reported. Furthermore, as no such correlation was seen with other soy food products, taking into account the previous result, the involvement of Menaquinone-7 was being speculated. The previous study was a cross-regional study, but there are some more detailed observational studies called cohort studies that were also conducted. This is a 3-year follow-up study about the relationship between natto consumption and bone density in women. It was found that the higher the natto intake was, the more statistically significantly higher the bone densities were.
週間に4パック以上摂取している人たちで骨密度が高くなってきます。また男性の
Next, in a 4 to 5 year follow-up study on male natto consumption and bone mineral density, it was observed that the higher the natto intake, the higher the bone mineral density, especially in the group that consumed more than 7 packs of natto per week. And down here, we have a paper that was published in 2020 on bone fractures through bone density measurement only. It showed that the higher the intake of natto, the lower the fracture rate.
骨密度だけでなくて、納豆の摂取量が多いほど骨折も実際に低いということで、特に
In particular, the hazard rate was 44% lower in the group that ate more than 7 packs of natto every week, indicating a highly significant difference. Again, as no correlation between the amount of other soy food consumed and bone density was seen, the paper concluded that Menaquinone-7, which is found only in natto but not in other soy food, was responsible for the improvement. Before I go forward, I would like to briefly introduce the history of the development of vitamin K that was derived from natto. First of all, in the year 1051, the word natto was mentioned in an ancient document. However, there doesn't seem to be any evidence suggesting that the natto mentioned was the same as the one we're eating today. Before the Second World War, in 1919, Bacillus subtilis natto was isolated from commercially sold natto by a professor from Tokyo University. And since then, natto has been prepared by pure culture. In 1940, a record showing natto was being sold in the United States were found. Natto, so-called grandfather's food, in the United States, can be sold as a normal food. In 1997, during the period when the above-mentioned epidemiological survey was being conducted, we began commercial production of vitamin K2 by culturing natto bacteria. About 10 years later, Menaquinone-7 was approved by the EFSA as a novel food, and it became available in the United States, Canada, Brazil, and many more other countries. Presently, with Europe and the United States being the center, vitamin K2 and Menaquinone-7 are now available as food around the world. Next, I would like to share with you researches that are about vitamin K and bone health. In relation to bone health, vitamin K has been reported to not only be able to activate osteocalcin, but also promote bone collagen production, and impart its effect directly on osteoblasts and osteoclasts. As osteocalcin is a vitamin K-dependent protein that is produced by osteoblasts, it was expected that osteocalcin knockouts, in other words, mice that do not produce osteocalcin, should have thinner bones. But surprisingly, bone mass was found to be increased instead. However, another study showed that although bone mass increased, it became fragile. Thus, it was thought that osteocalcin does not simply carry calcium to the bone to make it thicker, but it also modulates the locationing of calcium in the proper position in the bone. Since this is consistent with recent research, this suggests that vitamin K may be more useful for bone quality than for bone density. Secondly, as mentioned earlier by Dr. Shirakawa, vitamin K2 promotes the production of collagen in osteoblasts, and we were able to confirm that Menaquinone-7 has a similar effect. As for the effects of vitamin K2 on bone cells, Dr. Yamaguchi and his colleagues at the University of Shizuoka have reported that vitamin K2 inhibits differentiation into osteoclast, induces differentiation into osteoblast, and has a positive effect on bone metabolism in general. Moreover, as reported by Dr. Shirakawa, Menaquinone-7 can be converted into Menaquinone-4 and thereby has the abilities to perform various functions. Next, I would like to share with you the results of a clinical study. In this study, instead of vitamin K of our company, Menaquinone-4, the type of vitamin K that is used in pharmaceuticals, was studied. Participants were instructed to take a daily dose of 45 mg of vitamin K per day, which is about 500 times the amount when taken in as a part of diet, for 3 years. After 3 years of administration of placebo, loss and worsening of bone strength was the result. But in the group that took Menaquinone-4 for 3 years, the bone strength was maintained all the way through, suggesting Menaquinone-4's ability to maintain bone strength. Secondly, this is a study where 180 micrograms of Menaquinone-7 of ours was studied for 3 years. In the placebo group, bone mass, bone strength, and bone mineral density all declined with statistical significance. But in the Menaquinone-7 group, there was no deterioration and bone health was maintained. Next, let's take a look at vitamin K and arterial health. In this epidemiological study, we divided participants into 3 groups according to the intake of vitamin K2 and compared them. And it was found that the incidence of heart disease, mortality from heart disease, and arterial calcification were all significantly lower in the group with the highest vitamin K2 intake. The study reported that inhibition of arterial calcification by vitamin K can in turn reduce the incidence of heart disease and mortality. In this slide, the results of another clinical trial are also shown. It was found that when 1 mg of vitamin K1 was given to the participants, dilatation and extensibility, which are indicators of the elasticity of blood vessels, deteriorated in the placebo group and the vitamin D-only group. But these 2 measurements were maintained when 1 mg of vitamin K1 was taken daily for 3 years. Here, a clinical trial where 180 micrograms of Menaquinone-7 was taken by participants for 3 years to assess arterial stiffness is shown. In the placebo group, the arterial stiffness remained unchanged for 3 years, but in the MK-7 group, the arterial stiffness was improved. Particularly, intake of Menaquinone-7 by participants whose arteries are already stiff had a positive effect, implying the particularly prominent positive effect on unhealthy individuals. From the results of the above human studies, it can be confirmed that vitamin K is beneficial not only for bone health, but also for arterial and heart health. Moving on, the activities of 3 different homologues of vitamin K are compared. Bioavailability and osteocalcin activation were used as indicators for the comparison. By comparing the intake of vitamin K through spinach consumption and that through supplementation, it is seen that vitamin K is very poorly absorbed for spinach, but readily absorbed for supplements. This is because vitamin K is absorbed readily when it is dissolved in supplements or oil. Menaquinone-7 from natto, on the other hand, is much more readily absorbed and has a longer half-life in the blood. Next, the changes to blood levels of vitamin K1 and MK-7 when taken continuously were compared. It was found that the blood levels of vitamin K1 did not increase even when taken continuously, but that of MK-7 increased rapidly to a level that is almost 7 times higher until the 2nd week, where it plateaued out. In addition, the osteocalcin activation capacity was compared. It was found that MK-7 activated osteocalcin 3 times more than vitamin K1. In particular, up to about the 3rd week after administration, not much difference was observed. But the longer the intake was, the difference in level activation by vitamin K1 and MK-7 became greater.
共同研究した方は、悔やんでいました。
Next, in a pharmacokinetic study, in comparison with Menaquinone-4, Menaquinone-7 was shown to be better absorbed and was detected in the blood even 2 days after the single intake. However, in the case of Menaquinone-4, where 420 micrograms were administered, although it is thought that the compound is being absorbed, it was not detected in the blood. Again, in a continuous dose comparison investigation, MK-7 was also well detected in the blood, whereas MK-4 was not found in the bloodstream. Therefore, from a nutritional point of view, MK-7 is superior to MK-4 because MK-4 is less likely to show up in the bloodstream. Moving on, the effect of MK-7 on the activation of osteocalcin was studied. When humans were given 72 micrograms of vitamin K, the level of activation of osteocalcin deteriorated rapidly. In contrast, the level of osteocalcin activation was maintained when 50 micrograms or more of MK-7 was taken in, further suggesting that MK-7 of 50 micrograms or more may activate osteocalcin. If we compare the effects of vitamin K1, MK4, and MK7 on the activation of osteocalcin, as described in the literature, to activate osteocalcin at a maximum level, relatively high doses of vitamin K1 and MK4 are required. But at a much lower dose, MK7 can activate osteocalcin equally. The amounts of vitamin K1 and MK4 here are not the amounts that can be obtained from diet. In that sense, we believe that MK7 could be better in terms of nutrition. From the above results, we believe that the bioavailability of MK7 makes it the best choice for the activation of osteocalcin. Finally, due to the high activity of MK7, there are concerns that it may promote blood coagulation, making it easier for the blood to coagulate than normal. Hence, we investigated the effect of MK7 on blood coagulation and found that even after taking 600 micrograms, a dose that is almost 6 times the normal dose, for 1 month, the PT-INR was unaffected and normal blood coagulation was not affected at all. In summary, we believe that globally accepted requirements, recommendations, and reference doses of vitamin K may be inadequate for proper bone and artery health. Of all the vitamin K2 homologues, Menaquinone-7 can be used to activate osteocalcin and matrix GLA protein at nutritional levels, and its efficacy has been proven in human studies. And it is believed that the high efficacy of MK-7 can be attributed to its high absorption and bioavailability. This is the end of my presentation. Thank you very much for your attention.